You've got yourself an Experiential Robotics Platform kit, and you're ready to assemble it for the first time. In this video, we will go over the assembly process for putting the whole kit together, as well as how to set up the programming environment to test and verify that everything has been assembled correctly. The kit comes in a box that looks like this. Go ahead and open it up and start pulling out all of the things inside. We will go over what all is included in more detail momentarily, but for now, just start pulling out all of the contents. There's also a sticker sheet at the bottom if you want to decorate your XRP, and this information card about FIRST Robotics if you want to learn more about that. You can also see at the bottom, there is a diagram of all the different items that are meant to be included in the kit. If you instead have the DIY kit, then when you open up the box, you will not have the 3D printed plastics, you'll have a different set of contents. You will need to 3D print the plastics yourself. Once you have everything pulled out, go ahead and unpackage everything. I will do this off camera. Here are all the contents after unpackaging. We have the 3D printed plastics that you can see here, the main control board and battery holder, motors and wheel accessories, sensors over here, and the servo. Let's get a clean workspace. Be aware that the control boards may ship with Kapton tape on the connectors, so you need to remove those. Additionally, the chassis may have support material in the back here that needs to be removed as well. We will start with the chassis and the battery holder. Go ahead and flip over the chassis. The battery holder goes in this compartment here. It needs to be oriented in a certain way where the corners where the wire comes out needs to be in this corner because there's a little recessed area. And then you want this section facing out so that you can swap out the batteries if needed without taking out the battery holder. The barrel connector needs to go through this hole in this corner right next to the arrow. So go ahead and feed that through. Then you can see there are little nubs in this compartment that grab onto the side of the battery holder. So what you can do is push one side in, make sure the cable is coming through, and then push on the other side to snap that into place. We will flip this over to verify the routing of the wires is sufficient. They should be flat against the battery holder and going through this little gap right here. You can see mine are not quite there. So in order to fix that, you can remove battery holder just by pushing it out. Get those wires arranged in the right spot, and then push it back into place to make sure that these are free to move and flat against the battery holder there. Now we will flip the chassis back over. The battery holder takes 4 AA batteries, which are not included in the kit, but we do sell them on our storefront if you need them. Any battery chemistry should be fine, but we recommend nickel metal hydride since they're rechargeable and can sustain a higher voltage under load than alkaline batteries. Assuming you have batteries, go ahead and install them into the battery holder. Take note of the orientation that is marked inside the battery holder for the orientation of each battery. Now we can add the battery retention bar, which prevents the batteries from falling out, which can happen sometimes with vibration. It inserts into these cutouts next to the batteries. We'll first insert the solid end into one side, either orientation is fine. Then the other side, give it a pinch and insert it into the recessed area right here. If you ever need to remove the batteries, you can just pinch it again to pull it out. That's it for the batteries. Now we will install the control board. Go ahead and flip the robot over and make sure this is not in the way. There are multiple features inside the compartment to keep the control board in place. There are notches in these front corners that will grab onto the front corners of the control board. There are these spring arms in the back that grab onto the back corners, and there's one more spring arm at the front here that pushes into these bumps on the back to keep the control board positioned. Again, make sure the wires here are flat. If they're bulged up like that, you can just gently push down to make sure they're flat against the battery holder. Then we can take the control board, first insert the top corners into those notches mentioned before, then you can push down on the USB-C connector to try to get it into place. If you just push straight down, then it probably won't grab properly. These arms need to be back in their resting position. That's just because the board is a little bit too far back. Just need to push it forward so that these arms are straight. If you ever need to remove the control board, you can pull these spring arms aside and then lift up the board to take it out. Once the board is installed, we can plug in the batteries with this barrel connector. If you have batteries installed, I would recommend doing a power test to ensure functionality so far. There's a power switch in the bottom right corner. Go ahead and slide it to the on position. You should see 2 red power LEDs next to the USB connector, and if you've got a brand new board, they come preloaded with code that causes the blue LED in the top right corner to blink and the RGB LED in the top left corner to cycle through rainbow colors. If you see that, then everything is working so far. You can go ahead and turn off power for the rest of the assembly to avoid accidental shorts or other problems. You may notice the low voltage LED on the middle left flashes briefly when turning power on or off. That is normal, but if it stays on, your batteries are likely low on charge and should be recharged or swapped for fresh batteries. Note that this is not a low battery indicator. It is an early warning indicator for potential brownouts, but it coincidentally starts illuminating when AA batteries are low depending on the battery chemistry. Now we will tackle the motors and wheels, so go ahead and flip the chassis back over. There are compartments at the back here for the drive motors and wheels, which have traction to actually move the robot around. These cages at the front here are what hold the caster wheels and support the front of the robot while it's driving. Go ahead and grab the 1-inch diameter caster wheels and put them into the front, then push straight down to snap those into place. For the drive motors, we want to install the wheels and cables before inserting them into the chassis, so we will push that off to the side for now. You'll need the motors, the wheels themselves, the rubber O-ring tires, and the 2 motor cables. The wheels go onto the motors with a simple press fit. There are 2 flat spots on the motor shafts and wheels that align with each other, so make sure you get those oriented correctly. You will also want to make sure that the flat side of the wheel is outwards away from the motor. The rubber O-ring tires slip over the rims of the wheels into the grooves. It can be a little tricky to do this. I recommend getting half of the tire seated into the groove, then roll the other half of the tire up using your thumbs. The cables both have a big connector and a small connector. The big connector is what goes into the motor, and it has little bumps that align with a cutout in the connector of the motor, so it only goes in one direction. Make sure you push it far enough so that the connector is fully inserted. Now with the motors prepared, we can insert them into the chassis. The motors go in these compartments here and need to be oriented a certain way. They should be oriented such that the cables are towards the front end and the wheels are facing outwards. First, insert the wheel side of the motor. Make sure that the top of the motor gets aligned with this little cutout here, and then push on the front side of the motor to snap that into place. Then we can do the same thing with the other motor. No need to worry about the cable right now, we can just leave it where it is. Note that both motors are identical, so they can go on either side. Now we can plug the cables into the control board. There are cable management bars in these areas here, so I recommend inserting the cables through these big sections right here, so that when we flip the robot over, it will take up all the slack that we need. There are 4 motor connectors on the control board, and technically the motors could be plugged into any of them, but the software libraries will assume that the left motor is plugged into the port labeled motor L, and the right motor will be plugged into the port labeled motor R. Note that these connectors only go in one orientation. The easiest way to tell is that the red and black wires go to the pins labeled plus and minus respectively. Do be very careful to insert the connectors straight. If one corner is inserted first, you can end up bending some of the pins inside the connector. This could prevent you from plugging in the connector completely, or one of the pins may not make contact, or some of the pins could get shorted together. If this happens, you can bend them back with a pair of tweezers, though be very careful to not cause further damage or fatigue the pins. If you ever need to remove the motors, you can push on them through these cutouts here to take them out of the chassis. Now that the motors are installed, we can work on the sensors next. Just like the motors, it's easier to do some pre-assembly first, so we'll go ahead and put the chassis off to the side. It's best to connect the cables to the sensors first. The loose ends of the connectors need to plug into the headers on the boards. Each pin of the header is labeled with some text, so we need to match each pin with the corresponding color of the cable. Black goes to ground, red goes to 3.3 volt or VCC for power, and these are standard colors for most electronics. The blue and yellow wires are the data pins. Technically, the data pins could be swapped, but the software libraries assume they are in a specific order. The 4 wires should go in order black, yellow, blue, then red. If you want a helpful mnemonic to remember the order of the data wires, black and yellow go next to each other like the stripes of a honeybee. With the cables attached, we will put the sensors aside for now, and we will attach the mounts to the chassis. Now, these could theoretically go anywhere on the chassis, but we'll do the normal configuration with both of these at the front middle. First, attach the line sensor mount to ensure it's properly centered. Align the nub with the notch in the bottom rail, and then push to snap it into place. Now we're going to attach the ultrasonic sensor mount. I recommend first inserting the side next to the line sensor to make sure it's centered, and then push on the other side to snap it into place. With those attached, we can start working on attaching the sensors. It's easier to start with the line sensor mount. It needs to be oriented with the wires on the front side of the robot facing the top of the robot. Remember that we're upside down here. The back edge can first insert into the groove of the line sensor mount, and then push on the other side to snap that into place. Now we can attach the ultrasonic sensor mount, which goes in front of the wires of the line sensor. So go ahead and pull those back. Then make sure the ultrasonic sensor is pointing forwards with the wires towards the top of the robot. Insert the bottom edge into the mount, then push on the top to snap that into place. Now we just need to plug the cables for the sensors into the expansion connectors at the top of the control board. Note that these connectors are not all completely interchangeable. The two quick connectors are intended only for I2C devices to connect. The pins theoretically could be used for other purposes, but we don't recommend this unless you know what you're doing. Additionally, the IMU connects to the connector labeled Quick 1, so connecting non-I2C devices will likely cause problems with the IMU or even damage. Only the line sensor connector has pins capable of reading the analog voltage from the line sensor, so it must be connected there, and therefore the ultrasonic distance sensor must go to the connector labeled DIST. Before plugging in the cables, it's a good idea to do some cable management first. There's a few options, but I recommend inserting the cables into these slots in the front of the chassis here. Make sure you get the line sensor on the left and the ultrasonic sensor on the right, since that's where the corresponding connectors are. Then we'll flip the chassis over, and we can insert the cables through the adjacent slots going in front of the motor connectors to ensure that the cables don't get wrapped around each other. Then we can flip the chassis back over and plug each connector into its corresponding connector. Just like the motor connectors, these only insert one way. The easiest way to tell is that the red and black wires go to the pins labeled 3v3 and ground respectively. Again, be very careful to insert the connectors straight. If one corner is inserted first, you can end up bending some of the pins inside. This could prevent you from plugging in the connector completely, or the pins may not make contact, or some of the pins could get shorted together. Again, if this happens, you can bend them back with a pair of tweezers, though please be very careful to not cause further damage or fatigue the pins. The last part of the assembly is the servo. The servo mount can attach to the rails anywhere, though we'll go with the normal configuration at the back center. Note that it needs to be slightly left of center so that when the arm is attached, that will be centered. You may find this position of the servo to be a little bit annoying when plugging in the USB cable, so you can instead mount it off center if you prefer. The mount has this nub which inserts into the top rail like this, then push on the bottom end to snap that into place. Now we can attach the servo. This should be oriented such that the output shaft is facing to the right and closer to the front of the robot. Then we can just push it between the arms of the servo mount and push down until the arms grab the servo. If it's not fully snapped back, make sure you push down all the way to make sure it's snapped into place. Now we'll prepare the arm that attaches to the servo. We'll need the arm itself and the bag of servo horns, from which we will need the single-ended horn. The thin end inserts into this hidden slot. Make sure the flat side is down like this, then push all the way until it snaps into place. Now the arm can be attached to the servo by pushing the horn onto the output shaft of the servo. If you've never used servos before, they typically have a limited range of motion. I recommend rotating the arm back and forth until you find the mechanical end stops. Don't push too hard because there are small plastic gears inside that could break if you push too hard. I recommend rotating the arm forwards until you find the front end stop, then reattach the arm facing fully forwards between the headers of the control board. This will give you the maximum range of motion for the servo and allow you to put it all the way forwards for storage to make sure it doesn't wiggle back and forth. The headers will prevent it from moving. Servos also typically come with screws to secure the horn to the shaft. We would recommend adding the screw for extra security if you have a screwdriver handy, but it's definitely not required. We said this robot can be assembled with 0 tools, and we mean it. The arm usually stays in place reasonably well without the screw under normal use, and only really comes off if it gets snagged or something weird happens to it. If the arm does fall off, it's easy enough to reattach. Your mileage may vary. Now we can plug the servo cable into the control board. There are 4 servo headers available, And technically you could plug it into any of these, but the software libraries will assume it's plugged into the connector labeled Servo 1. For cable management, I recommend first inserting the cable through this rear slot. You can flip the chassis over, pull that all the way through, then insert it through the frontmost slot back here outside of the sensor cable to make sure they're not wrapped around each other. And then we can insert it into the Servo 1 header. Be aware that this connector is not as foolproof as the others, so make sure the orientation is correct. Black goes to ground, red goes to 5 volts, and white goes to the I/O pin. And that is the entire assembly. As you can see, the whole kit can be put together in just a few minutes with 0 tools required. Before calling it done though, I would recommend doing a few more tests to verify that the assembly has been done correctly. I would actually recommend starting with the power test again to verify that nothing went wrong during the assembly. Flip the power switch to the on position again, and you should see all the same LEDs illuminate as before. If not, there's a problem somewhere and you should double check your wiring to see where the problem might be. If you have a problem and need to diagnose it, I would recommend unplugging all the cables except for the batteries one at a time to see if unplugging one thing causes the problem to be resolved. Though be sure to leave the battery connector still plugged in. If unplugging one cable causes the LEDs to be fixed, then there's probably something wrong with that cable. Double check the wiring to make sure everything is plugged in correctly. If you unplug everything except for the batteries and there's still a problem, then it's likely something on the control board was damaged somehow during assembly. If you only see one of the power LEDs on, then it's likely one of the pins in one of these connectors got bent from inserting the cable at an angle instead of straight. Once you've verified the board can still be powered from the batteries, flip the power switch back to the off position. That simple power test is good, but it will not detect all possible problems. For that, we should get set up with the software environment to test everything else. You will need a computer of some kind. Any operating system should be fine. Even a Chromebook works because the software environment runs in a browser. You will also need a USB cable with a Type-C connector for the control board. It is also possible to connect over Bluetooth to the code environment, but we'll just be demonstrating with the USB cable here. Note that the cable is not included in the kit, but we do have them available on our storefront. Once you have a cable, plug one end into your computer, and then plug the other end into the control board. Note that even with the control board's power switch in the off position, the computer still detects the board was connected and almost all the same LEDs illuminate as before. That's because the core system power is always on when USB is plugged in. However, to power the motors and servos, that power is only available when the power switch is in the on position, and that power can come from either the battery or the USB connector. Now on your computer, open a web browser. Note that some browsers may not work, so we recommend using Google Chrome. In your browser, go to the search bar, then search xrpcode.wpi.edu, and that will bring you to this page. This is the main code editor that is used to interact with and program the XRP. If there have been any updates since the last time you connected, you'll see patch notes like this that you can read to learn more about what changed. We'll cover a few basic things about the editor here, but if you want more resources, look under the Help menu at the top. Here you can access the XRP user guide, API reference, curriculum, and online support forum. We'd recommend looking at these after you've verified the XRP has been assembled correctly, but for now, we need to connect to the XRP. Click the Connect XRP button in the top right corner. It will ask if you want to connect via Bluetooth or USB. Since we're doing USB, we'll click that one. Then in the top left, it will ask you for a device to connect to. Assuming you only have the XRP connected, you should only see one option. If not, try a different USB cable. Some very cheap USB cables omit the data wires and provide only power, so swapping to a known good USB cable will help. Also make sure that your computer recognizes the control board and that your drivers are up to date, or you can try a different browser. Again, Google Chrome is known to work with the XRP code editor. Once you find your board, select it, then click the Connect button. After a moment, there will be some messages at the bottom, which means you're connected to the robot. If your MicroPython version needs to be updated, you'll see a message like this. Click the OK button. A second prompt pops up for instructions of what to do next because you'll have to inform it of the right spot to install MicroPython. Click the OK button. The XRP will disconnect and reconnect as an external drive. You may get two windows like this. One is the drive that the robot shows up as, which we do not need right now. The other is the window to select where that drive is located. Go ahead and select that, then click Select Folder. Your browser may pop up a warning that you're about to give permission to the site to edit the files on the drive, which it needs in order to update MicroPython. Go ahead and click Edit Files, then wait for the progress bar to finish, which will take a few seconds. Once that's done, it will disconnect and should automatically reconnect as before, but if not, you can click the Connect button again and go through the same steps to reconnect. If the library files need an update, you will see a message like this. Click the OK button, and then you'll have a progress bar showing the process of the files being updated. Now that everything is updated, we can quickly verify MicroPython is working by entering some Python code in the bottom window here. For example, if we type print 1 plus 2, it should spit out 3. That means that MicroPython is working. In the main window, you have the option of creating a new Blockly or MicroPython file. You can play with these right away if you want, but we recommend you first run the installation verification example to confirm everything is working correctly. On the left, there's a file browser showing all the files stored on the XRP. Expand the XRP examples folder, then double-click installation-verification.py to open that file. You can read through all the Python code to see how it works, and when you're ready, click the Run button in the top right corner. If the power switch is off, you'll be prompted to turn it on. All the sensors will work with the power switch off, but it must be in the on position for the motors and servos to work. Go ahead and do that now. You should see the second power LED illuminate. Then click the OK button to let the code run. After a few seconds, text will be printed at the bottom, which is the same text from the Python code up above. You'll see on the control board that the monochrome LED starts flashing rapidly. This example will run several tests, and it requires you to push the user button in the bottom right corner to go through each test. Press the user button, and it will start printing measurements from the line sensor. Pick up the robot and cover each sensing element to verify the values change from 0 to 1. Also verify the left and right are correct. If not, double-check your wiring and verify there are no bent pins in the connector. Press the user button again, and it will start printing measurements from the ultrasonic sensor. Move your hand in front of it to see the measured distance in centimeters. If it's not working, again double-check the wiring and verify no bent pins in the connector. Press the user button to continue. The next test will move the servo, so keep your hands clear of its motion. Also ensure the power switch is on, then once you're ready, push the user button again and the servo will move after a second. If it doesn't move, double check the cable is plugged in correctly and that the power switch is on. The last step will drive the robot around to verify the motors, encoders, and IMU are all working. It will drive forwards 25 centimeters, turn left 90 degrees, then turn back and drive back, so make sure you have clear space for this. You can pick up the robot if you don't have enough space, but the drive functions use the IMU to verify the orientation of the robot, so you will need to physically rotate the robot for each step to complete. Watch the rotation of the drive wheels to see what direction the robot is trying to turn. If you let the robot drive around, be careful of the USB cable. You may need to guide it around to ensure it doesn't get caught or tangled in anything. You can even unplug the USB cable at this point. If you have batteries installed and the power switch is on, the code will continue running. Once you're ready, press the user button and the robot will start driving. Now that you've verified everything is working, you're good to get started on your first project. Check out our other XRP content on how to use everything in more detail, and if you ever get stuck on anything, then check out our support forums for help as needed. As always, stay safe, be kind, and happy roboting.